Good afternoon. This is Nick Mosley. UTC ID is KHY111. This is going to be problem 3 using bisection search to make the program faster. So in the previous program, monthly payment had to be a multiple of 10. This one's going to make it a bit more accurate. It is going to be within the cent. Um, and so what we are going to do with this one, we still have some similar parameters here. So balance of $5,000. Our annual interest rate is still the 0.18, just per the other prompts. I went ahead and set a monthly interest rate variable, the MIR. So it'll be the annual interest rate divided by 12. And then also in the prompts, there were the lower bound and the upper bound was given here. So the lower bound will essentially be the balance, $5,000 divided by 12, which would, be a good starting point because that would be just the straight payment if there wasn't any interest attached. Similar deal with the upper bound. That would be the calculation of just base 5,000 with the compounded interest divided by 12, which, wouldn't account for monthly payments here since it would just always be calculating off that initial 5,000. So essentially the whole premise of this sort of division, the bisection search, is to take the median, so add the low and the high, divided by 2, and that's how we'll get this squared away. So what I did, set up a Boolean statement here, set up a new variable to put the subtraction in here. So the new balance is going to equal the balance. So when we do first start this, balance will be initialized as 5,000. Then we'll just go into a for loop, a nested for loop inside the while statement. So in the range of 12, so in the 12 months, we're essentially going to take that initial balance and then subtract that payment, which was calculated off that initialized of the 5,000, the high and the low, and then divided by 2. So we'll subtract that, and then we'll add the monthly interest rate here, or multiply that by the new balance and then add it to the new balance to get an even newer balance, a more accurate calculation there. So essentially it'll run that 12 times, kick it down here into this to essentially see if we have paid out an accurate amount. So essentially, if we had set that initialization just for easy numbers here, we'll say that the low balance was, or excuse me, the lower bound rather was $2,500. That was our first initialization. And that was correct. So, we would print out the monthly payment, $2,500, if we, excuse me, if we did that math and then it was, if we were after 12 iterations, there was a remainder of $5. Our new lowest parameter would be 2,500 and our high balance would be higher than 2,500. Similar deal. So high bound, or excuse me, upper bound, same deal. So with $2,500, if with a payment came out to that, and then we went through 12 iterations and was like -1 to infinity, the 2,500 would be the upper bound. And so that'll set the parameters to kind of make sure there's like a bit of a rubber band effect and make sure that the low and the high don't get too out of sorts there. And then as it initializes that, so, for example, if the 2,500 is the lower bound, it would now initialize that to be 2,500 plus whatever the initial calculation was on the upper bound here, and vice versa. So if the lower bound was, it initializes, well, not at 0 in this case, but whatever that balance would be, then that 2,500, if that were to be that calculation, was found to be too high, and it would come here and then reset as the new parameters here to be recalculated out and then to go on, so on and so forth until we find it. But it's roughly 500, or excuse me, $451.61 is how we'll find it. So I rounded it to, the nearest cent, and then sent out that minimum monthly payment. And that is project 2.3. Thank you.